The friction and the magnetic force.
Yeah, friction and the magnetic force are working. For magnetic, for a rod, the magnetic force is ILB. 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 Are my annotations visible?
Yeah, they are. I'm just writing it directly on the OneNote page.
Okay, yeah,
So if you write something, I'll just write it too.
yes. ILB. So we have to find what is the current in this current running in the circuit, in this circuit. Mhm. So for current, we need first the EMF induced. EMF induced is delta flux by time. Flux is basically B dot A, and we have to find delta over time. So how is it? B is constant. Yes. B is how much? B is this 0.8, and area will change because it is area is increasing with the rate of the velocity.
Yeah.
So this can be written as B is constant, so it can be taken out delta area upon delta T. So delta area upon delta T. This length is constant, but this length is increasing with the velocity this much.
Yeah.
So delta area upon delta T will be 0.52 into 1.8. This can be written as 0.8 into 0.52 into 1.8. So this is the EMF generated in volts. All is EMF generated. Hmm. I think you're using your mouse.
Yeah. Uh, yeah, I'll just type this part. It wouldn't, so okay, so you get 0.52 times 1.8. That's the area when it starts, but that's not the change in area, is it?
That's change in area because 1.8 is the velocity by which this rod is moving. So the
Oh, okay. Then
yeah, so area is increasing by only one is I can write this area is what? Length into breadth. Okay. So delta area by delta time means I'm doing delta L into B upon delta T. So my length is constant. Again, I can take it out from the derivative part. And what is the change rate of change in breadth? It is
1.8.
yeah, velocity or
Okay. Yeah.
that's should I erase this? Should I keep this? Yeah,
You can erase this part here.
this part I can erase.
Actually, yeah, you can erase. Yeah. Okay. So then we have
I have the EMF induced. This is the EMF induced 0.8 into point. If I calculate that
0.7488.
0.7488. Okay. So and EMF induced is equal to current into resistance in the circuit. My current will be given by EMF upon resistance. 0.7488 by 3. This is 0.24.
0.2496.
0.2496. This is the current in amperes. Next is I'll find out the force using this current. Length was already there. Yeah, magnetic field, magnitude of magnetic field was there. Next is I need the force. So the force will be given by this formula only.
So the length would just be 0.52, right? Or
Yeah,
that,
in a point of 0.5.
okay. So just take 0.8 times
0.2496 times 0.52 P. E is what? 0.8. This is 0.1038 unit. The calculate magnitude of current we have calculated. Yes. First magnitude of force required. So this is the force which is pulling it backwards.
Oh, okay, yeah, this is the force pulling it, um, the magnetic force, right?
Yeah.
So then we need to find the force pulling it to the right.
Yeah. And for that we will this is the rod.
You
Two
find the
forces.
friction force. Yeah.
Yeah. One is the force due to induced current and magnetic field. Second will be the force of friction. And combining both should be the force which is pulling it rightwards. F external. So friction is given by okay.
Mu F or mu times the normal force.
Yes. Mu times the normal force. So normal will be equal to the mg, mass in times gravity. F normal. And F normal here will be equal to gravity. F gravity. Which is 0.22 kg times gravity is 0.98. No, 9.8.
The mu k is just 0.2.
Mu k is 0.2. I'm just finding the normal. You are calculating the total. Okay, directly you can calculate right. FK.
That's what I got for the friction force.
Okay. Now you have both the forces pulling it rightwards, leftwards. So you can calculate the external force, which is pulling it right. You can write F external.
How do you know which way the current is going in this?
Okay, so
Wait, no, no. You have to like put your thumb down and then curl your fingers, right?
yes. But I inferred directly because uh, what the force should do, the force should oppose the change in flux, right? So
Yeah,
flux is happening because this rod is moving rightwards. So intuitively, I got the force should be leftwards. But we will come to it through other way also.
yeah.
Okay.
Okay.
So the flux is increasing in the no, inside the plane, no? Cross.
Yeah.
Flux is increasing inside the plane. So the current must be such that the generated field is outside the plane.
So counterclockwise.
Yeah, counterclockwise. Now we have to find the force. So that is in the direction of current, point your fingers in the direction of current and curl them towards the magnetic field. So point, right hand fingers straight up. If I move them away from me, the thumb points left hand side.
Okay. Yeah. Yeah, I get it. So the
Hmm.
force to the right is this plus this.
Yes. E plus FK, yeah. What is the energy dissipated?
So 0.535 newtons.
This is the force that should pull it rightwards. Calculate the energy dissipated in the resistor. Okay. So the heat rate of heat dissipated or power is given by
Energy over time.
VI, or in the electrical circuit, it is the power, formula for power.
So
Or
I
I,
squared R.
yes, we can use any, have both I and let's use this I for I square R. Power, that's also.
It's just faster than writing it with my mouse.
Yeah.
And on this laptop, I don't have a stylus, so it's my touch screen. So,
Mm-hmm.
So we have current. Let's just do, okay, so 1.8.
One was the
1 point is the velocity, right?
no, V is the voltage.
Oh, oh, sorry. Voltage is the E, the induced
Yeah,
EMF.
induced voltage, EMF.
Induced EMF is this.
This is the power. So in 2 seconds, uh, we have to multiply it by time to get the energy dissipated. Yeah. This is in joules. Yeah, this will be in joules.
Okay.
Okay. Next is work done. So work done is given work done by the string pulling the rod in 2 seconds. Okay. Work done is
Equals energy over time, right? Or no,
yeah,
okay. Power equals work over time.
yeah. Power equals work over time. That should be same. This should be same as the energy dissipated. And we can calculate it also. It should come as force times the distance.
Yeah.
So the F net also you calculate it by this F net into 2. It should come same ideally.
Right.
The
Would it be 2 times the velocity?
two times the velocity. Two times velocity.
Because the change in uh this like the distance traveled in 2 seconds, right?
Uh, yeah. Oh, no, you are yes. This is 1.8 times 2, 3.6. Work done equals to heat dissipated. 0.5. What was okay?
The F net.
Mm-hmm. Sorry. Heat dissipated won't be equal to work done because some amount of work is done in moving the rod. Hmm. So actual work is done. Hmm. I was wrong. All the energy is not going in dissipation. The rod is also moving. Hmm. Okay. This is not correct. This is correct. What I was thinking was wrong. Hmm.
Okay. Either way, it says to calculate it, so I can't just write the answer.
Hmm. Compare your answer in C and D. Yeah, friction is also doing, na? Hmm. There is friction also.
Okay.
Friction and
Wait,
this also.
what's the units for work?
Work done is
Watt.
joule.
Okay. Isn't power in watts?
Power in watts, yeah. Energy dissipated in heat. So that's why we have
Okay.
multiplied it by time. So now it
Yeah. Okay. Because power is work over time.
yes. So compare your answers. by C and D and provide a physical application. So they are unequal. We can see that because friction is also doing friction and magnetic force are also doing work. Negative direction. We can calculate there also. Uh, Work done by friction and work done by magnetic force.
Yeah, for these, if it doesn't ask, we just don't calculate it because we're trying to do these quickly.
Yeah, okay.